Good afternoon, everyone, and welcome to today's Husky webinar. The topic of today's webinar is increasing profitability of high output systems in a rapidly evolving PET market. Thank you for joining us this evening. My name is Ben Daniel. I'm the Chief Editor for Packaging Middle East and Africa magazine, and it's a pleasure to be a moderator of this session this afternoon. Today's discussion comes at a very relevant time, especially for PET producers and packaging converters. We see rising energy costs, and we also see labor shortages, tighter margins, and growing pressure to use higher levels of rPET, recycled PET. Manufacturers are under increasing pressure to improve efficiency without compromising on quality or on the output side of it. In this webinar, we will look at practical strategies to help reduce cost per part and improve profitability in high output PET preform production. So as delegates, as we are all signed in, so there's some very interesting takeaways that we'll be hearing from our speaker this afternoon. What are they? The real drivers of preform cost at scale. And we also will hear how to maximize output per system, per cycle, and per square foot of floor space. And we also will be looking at why consistent rPET preform quality is now not only a compliance issue, but also a cost issue. And last but not least, we'll also hear about how Husky's HyPET 6E platform supports producers in achieving a lower total cost of produce. So, we are pleased to have here with us Philip Parubets, who is the General Manager for North, Central, and West Africa at Husky Technologies. A few words about Phil. He's got a long experience in this industry. So Phil has been with Husky since 2006, and he has held several technical and management roles across rigid packaging, operations in Canada, in Singapore, in China, in Thailand, and also in the UAE. Before we begin, a small request to all our attendees to place your questions in the Q&A box on the bottom during this session. Please feel free to share your questions because it's a very interesting topic that we're going to be hearing from Philip. So we'll take them in the end of the session, end of the presentation. Your questions will be answered. So with that, I'm pleased to hand over to Philip to begin his presentation. Over to you, Philip.
Thank you, Ben, and thank you to Packaging MEA. It's good to be here with you again. It's been over the years. I've been honored to be given the opportunity to present with Packaging MEA and to all of you out there. So let us begin our presentation here. So let me begin with an introduction about Husky. So Husky, we have around 4,300 people around the world. Our main headquarters are in Bolton, which is near Toronto in Canada. We also have a head office in Luxembourg in Europe and also in Shanghai. We have equipment around 440 countries around the world. And if you'd like, our mission statement, our purpose is to enable the delivery of life essentials in a safe, affordable, and sustainable way. When I talk about life essentials, I'm talking about foods, I'm talking about beverages, I'm talking about medicines, and all of the things that we need to sustain a healthy and prosperous living. Our main industries are in, I would say, in the beverages and foods and beverage industry. Around 65%, 75% of our business is focused on in those consumer packaged good segments. And then we also have a presence in medical applications. And we also sell equipment to the wider rigid packaging space, making all different types of consumer package items. Husky is an old company. In fact, we started around 1953, and we developed our first injection molding machine here on the illustration on the left. In 1961, our very first injection molding machine making these one cavity mold, produced a little plastic cup. And about 15 years later, we produced our very first injection molding machine for PET systems. And this was about the time that PET packaging was first developed, around the mid-1970s. So we were there since the beginning for PET packaging, providing solutions, injection molding solutions to make preforms. and later blown into bottles for the beverage industry as early as the late 1970s. And since that time, we have continuously evolved our technology, our platforms from the 1970s. In the first 20 years, we had, some of you on the call might remember, we had the X line and the G line for the first 20 years. And 2004 was a milestone because we introduced our very first HyPET system. And up until today, we're still based on this HyPET platform. 3 years later, afterwards, in 2007, we launched the HPP, the high performance package version of HyPET, to produce faster cycle times and more aggressive preforms. And over the years, we continue evolving with new technologies to support our customers in different ways. In 2010, we introduced the very first rPET flake machine to support the recycling industry. So we were there even more than 15 years ago to support the recycling industry. And we also, in 2016, we introduced a multi-layer machine. This is a 2-material, 3-layer preform, an engineered preform that performs better than a regular preform in a number of applications, for example, shelf life and other characteristics of the preform. And up until today, now we have the HyPET 6E and HPP 6E as our current flagship platform, and also the NX6 system. So as you can see, many years of evolution, and all throughout the years, we improved our productivity, we decreased energy consumption, the ease of use got better, our capability to run rPET has improved dramatically since we first introduced the PET system more than 45 years ago. And in that time, we have sold over 6,500 machines, HyPET, PET injection molding machines around the world. In the region where I'm serving in Africa, we're seeing an explosion of growth in the region. In South Asia and Southeast Asia, we're seeing enormous capacity being added in those regions, as including in the Middle East. And with all that experience, with all the installed base, we can comfortably say that we are the most experienced in designing injection molding system solutions for any type of preform product, any type of whether it's beverage, whether it's food packaging. We have over 73 years of experience supporting the industry. And just a bit of trivia for you, all around the world, we produce around 16,000 preforms are made every second on Husky machines around the world. And this goes to show you how much experience we have in the consumer packaged good industry with regard to PET packaging. So let us now turn our attention to the main theme of this presentation. And here we're talking about profitability of your preform injection molding operation. And when we talk about profitability, there are really two elements here. On one end, if you take a look at your income statement, the top line is your revenue. So anything that you can do to increase your production, to increase revenue, whether you can sell more preforms or whether you can use those preforms to produce more bottles, this will all contribute to increased revenue and increased profitability. And on the other end of your income statement, you have your bottom line costs here. And here is an example here of the most important bottom line costs that you would see in the income statement. And what stands out here really critically here is that when you look at the cost of producing a preform, the number one most expensive contribution to that, to the cost of goods sold, is your resin cost, of course. And anything you can do here to reduce the weight of your preform, to reduce scrap of the preform, to reduce purges, anything that can reduce your resin consumption will go a long way in reducing your cost of goods sold and reduce your bottom line costs. Putting aside the resin costs, other very important costs is your energy costs. This is also, when you look at the income statement here, you're looking at the cost of goods sold. So you have their element of fixed cost with regard to energy, but most of it is variable when you're running a machine. And also your labor costs here. There's a variable contribution and there's a fixed contribution, but both of them are an important contributor to your overall operating costs. In some regions, the energy costs are more impactful than the labor costs. In other regions, it'll be the other way around. But we can say that when you compare to all of the other elements of your operating costs, energy and labor are two very important contributors to your overall operating costs. And then, of course, we have your capital depreciation of your assets. Is also an important consideration here as well. But really, when you're talking about over a long time horizon, When companies talk about profitability, we talk about things like conversion cost, right? Dollars per ton. We also talk about, in the vernacular of profitability, we also talk about machine run rates, right? We also talk about part cost per thousands. If you want to reduce these costs, your conversion costs, your preform cost per thousand, your machine rate, it is critical that you find ways to reduce your energy costs. You increase your production, so you can take your fixed costs and distribute over a larger production base. Reduce your labor costs, and et cetera, et cetera. So we'll be talking about all of these themes throughout the rest of the presentation. So energy is an important contributor to your operating costs, and as Ben mentioned at the beginning of this presentation, we're seeing a lot of variability. So there's a lot of pressure coming to the industry today in the consumer packaged good industry. Pressure is being applied at the front end in terms of revenue, in terms of purchasing power being impacted, and we're also seeing bottom line costs, operating costs going up. And two important contributors here are energy costs. I don't need to say much more on this. I live in the Middle East today, and we're seeing all of the impacts of that and the reverberations of what can happen in one part of the world, how we can reverberate to increasing costs in the rest of the world. And we're seeing this specifically for energy costs here. For labor costs, there's also the challenge of cost for labor, especially in some markets around the world. But what's really acute and what's really universal with regard to labor is the fact that it's very difficult to find good technicians, good reliable technicians, and not just technicians, but the good factory planners, good production planners. It's getting more and more difficult to find good people. And one element, a lot of people don't jump into these type of careers when they start their career, and a lot of people who have a lot of experience are moving on and retiring. So it's becoming more and more challenging to find good people to run your machines, and this is a very important part of the operation. So we at Husky, we're putting a lot of importance, we're placing a lot of importance in developing our machines to be as user friendly as possible, to be as predictive as possible, to be self-autonomous as much as possible, to reduce the impact of labor as much as possible. And we also offer services like Advantage Plus Elite, where we support our customers in running the machine. So we will talk all about this later. And as I mentioned on the other end, when we talk about profitability, we're not just talking about operating costs, we're also talking about pricing pressure from the other end. So whether you're a bottler and your consumers at the other end are not willing to absorb any higher costs, if you increase the price of your products as part of your OBPPC strategy, they will switch to a different brand, or they will switch to a different category altogether. They simply cannot absorb any more costs. So as a bottler, you're feeling pressure from the consumer end. And if you're a converter supplying preforms to the bottler, you're also feeling the pressure, because as the bottler is feeling pressure from their end, they're translating the pressure to you as well. So you're being squeezed on both ends, from the top end of your income statement and also on the bottom end. And here at Husky, we're trying to find solutions to support you on both ends. And to add to the complexity, we're also seeing that many countries around the world have in the past introduced legislation for rPET. And here I'm talking about in North America, Latin America, and in Europe especially. But we're also seeing legislation being passed in India. The FSSAI has introduced legislation a couple of years ago mandating minimum recycled content, and we're seeing similar type of legislation being introduced in Africa as well, and Southeast Asia. So we're seeing this rPET is really being driven by legislation, and the stakeholders in those countries must find a way to incorporate rPET into their packaging. And so we already have a difficult situation with profitability being squeezed on both ends. Now we have another variable, which is the introduction of rPET. And the reason why rPET contributes to the complexity is that rPET cannot be considered as a drop-in replacement for virgin PET. rPET itself is a variable material, and it depends on the quality of the feedstock coming in. It depends on the makeup of the feedstock coming in, the processing that converts the bale into the pellet. There's many elements that goes into the manufacturing of rPET that increases the variability of the material. And what we have found in the last 15, 20 years in supporting customers running rPET is that In some cases, we have to increase cycle times to be able to mitigate the risks of running rPET. Sometimes we have increased downtime. We've seen that some customers have increased scrap rates. They have to clean the molds more often, and they have more inconsistent preform quality. So all of this contributes to increased bottom line costs here. Your energy cost goes up, your available time goes down, your downtime increases, your scrap rate increases. So it's really important that when you think about using rPET, you really need to find the right solution, the right partner in terms of services, in terms of equipment, to try to mitigate that variability as much as possible. And this is where Husky can support in a very systematic way. And I'll talk about that in the next slide. So here today, this is our current catalog of our platforms. So we have, at the beginning here, we have the HyPET 6E platform, which is our latest and greatest platform, which was an evolution of our 5E platform a couple of years ago. And this is what we call our kind of a high output segment for preform production, 200 million and above. And we have clamp sizes from 225 tons up to 500 tons, and screw sizes from 85 millimeters up until 155 millimeters, with cavitations up to 200 cavity molds. We also have our NX6 platform, which supports the mid-volume segment between 150 to 200 million. We will not be talking about this platform in this webinar, but I'm sure that in the future we will be introducing separate webinars to talk about the NX6 to target that market. And then we have our NXPET targeting, which are our lower end of the mid-volume between 30 million to 150 million preforms. Both the NX6 and NXPET are very flexible for a lot of mold changeovers. We know many customers who operate in this segment have many SKUs they have to run. So these two platforms are designed and very specific to operate many different SKUs. Now let's focus on the high output, which is the HyPET 6E platform. So the latest generation, the 6E, was launched in NPE in Florida in May of 2024. And during that show, we introduced our 144 cavity on a 400-ton machine. Historically, it ran on a 500-ton machine. We're able to now put that mold in a 400-ton cavity press. It was running 100% rPET at a very aggressive 4.3 second cycle time. And a couple of years later, at DrinkTech, we enhanced this technology. In September of 2025, we launched a 200 cavity in a 500-ton press, also running 100% rPET. And here, the goal here is to make sure that we can perform, we can keep up with any filling line speed there is globally. So this particular system was able to produce 128,000 preforms per hour, which can keep up with any filling line that exists today in the market. And this particular system also included our revolutionary vacuum dryer, which I'll also talk about in a moment later. Up until today, we have nearly 300 orders, 200 systems running in the field. Half of them are our 6E platform, and then the other half is our HVP6E platform. And we're seeing this system being adopted all over the world, in Asia Pacific. Here we're talking about East Asia and Southeast Asia. We're seeing in Middle East and Africa, where I support. We're seeing a wide adoption of this platform, and also in North America and Latin America as well. So when we talk about the HyPET 6E, when we're talking about developing this technology, our critical focus was on delivering for a customer in 4 key areas. Number one, to make sure that we have the fastest industry's fastest cycle time. Number two, to ensure that we produce more preforms than ever is possible. We have the industry's highest output, reducing energy consumption to the greatest degree, and finally, to ensure that we have all the technologies enabling the highest quality preforms running 100% rPET. And here's an illustration of a number of technologies that we introduced specifically for the 6E, and we'll be talking about them in the subsequent slides. So the first technology is our new high mix screw. So for those of you who are familiar with our injection molding systems, in the past, we had 2 different screws. We had our high flow screw, which is optimized for energy efficiency. It was optimized for high throughput, melting plastic at a very fast rate. It was optimized to minimize your acetaldehyde. That was one type of screw, and very applicable for virgin PET, It was very applicable if you didn't have anything to mix. There was no colorant, there's no additives. You just wanted to melt virgin PET as efficiently and effectively as possible. That's high flow. For those customers who ran rPET in the past or who had a high dosage of liquid colorant or other additives, here we would offer them the mix-cell screw. And as its name suggests, it was really good for mixing. The challenge is, how do we able to get the best combination of both? There's kind of a contradiction here. One screw is very good for AA, energy efficiency and throughput, and the other one is good for mixing. But today, when customers are running rPET, they need the best of both worlds, and we developed a high mix screw, which is really the best combination of both. High throughput, better acid aldehyde management, excellent mixing, excellent energy efficiency, and in fact, the throughput of this screw is even better than the traditional high flow screw. And what this means, in some cases, in some applications, we're able to size a smaller injection unit than what you would have in the past. For example, an application that you would need maybe a 100 millimeter screw in the past, with a high flow screw, you can use EE85 today with a high mix screw. So this is really quite a revolutionary screw, and we support a customer in terms of being able to process rPET and at the same time enabled the possibility of reducing the footprint of the machine, reducing energy footprint as well, because they're using a smaller screw in some cases as well. Another innovation we introduced, and here this is support our customers to improve profitability by increasing their top line production to make sure they're able to produce as many preforms as possible. And this is very helpful to reduce your conversion cost, to reduce your part cost, to reduce your machine run rate, because you are producing a larger number of preforms over fixed cost base here. And how we're able to achieve that is we introduced a 45 pitch high density mold, which we'll talk about in the subsequent slide. We also introduced the largest 38 millimeter mold available with the 144 cavity mold, now being able to run a 38 millimeter pitch preform, where previously we were capped at 128 cavities. And now we also introduced our 200 cavity system, enabled to run up to 30 millimeter threads. So let's talk about each of these in a little bit more detail. And starting with the 45 millimeter pitch. But this is really a great innovation here, because historically, if we're talking about X lines and G lines 40 years ago, where on a 2 to 5 ton platform, you can run a 48 cavity mold, and then in subsequent years we jumped to 72, and now we're able to squeeze in a 96 cavity mold in a 2 to 5 platform here, and that means your production increases by 33%. So whatever your fixed cost footprint is, you have your fixed floor space. Your cost associated with floor space, you're able to produce 33% more preforms, jumping from a 72 to a 96 cavity. And the same story applies to the 300, where we're able to move from a 96 cavity up into a 128 cavity. And for 400 ton, we're able to move from a 128 cavity to 144 cavity. All of this contributes to increased top line revenue and spreading your fixed cost over a larger production base. With regard to aseptic applications, we know a number of customers in dairies and juice use a 38 millimeter neck. And here we also introduced a new pitch size for our stacks. And this has allowed us to fit a 144 cavity in a 500 ton machine with a 38 millimeter neck, where previously we're capped at 128 cavities. And for many of our customers who are running large production runs of juices and dairy, this was able to increase their output by 15%, which is a very important contributor to their profitability. And finally, 200 cavity system, which was shown in Drink Tech, as I mentioned before. This is really a revolutionary change for us. We're able to increase our output from 160 cavities to 200 cavities by 25%, and able to maintain a cycle time here. And we made a number of innovations in our machines to be able to support that, including increasing the tonnage of the machine, redesigned the conveyor, the robot, the heat cabinets, the castings, all of that were adapted to run this very, very high output 200 cavity system. And we have a large install base of these systems going to be delivered around the world. Quite a large order intake of this platform. And the heart of our system is of course our cold half and our hot runner. And here, Husky has a number of exclusive technologies here. All of these technologies contribute to lower bottom line costs here. For example, first here we have mold identification, where we have mold ID tag. Every time you change out your molds, the HMI of your system will automatically detect which mold is there. It will load up the right program, so there's no chance of mistakes of running the wrong process. It speeds up the process in terms of changeover, that the right process is set up. It's synchronized, so this will here make it simpler for your technicians to be able to do mold changeovers with the right process being loaded. Integrated mold alignment is another great technology here. This is a technology where it ensures that every time your mold closes, the mold is properly aligned. And this makes sure there is minimum wear. So your need to refurbish the molds goes down, your mold life goes up, and here this reduces your operating expenses. Here we have also on the right-hand side, the self-cleaning technology here. In the past, it would take around 3 to 4 hours to clean your molds. This is a normal part of mold operations, where you have to shut down your machine, you have to clean your mold vents. It would take a couple of hours to do it, and it would take the effectiveness of this operation really depends on the capabilities of your technician. And we're able to automate all of that into, let's say, a 10-second operation where you press one button on the HMI and the mold will clean itself here. So this has helped both customers on the top end, where your downtime is now reduced. You're able to produce more preforms, and on the bottom end, because you have much less scrap right now. So all of this has contributed to, all the technologies have contributed to increasing top line revenue and to reduce bottom line costs. Another technology we introduced on our 60 platform is our dual servo pumps. Historically, we had one set of one pump, one motor, and one hydraulic circuit, both for the clamp side and the injection side here. Now we have completely separated those hydraulic circuits. There's one separate set of pumps, motors, and accumulators and circuits for the hydraulic side, for the clamp side, and the other one for the injection side, because their demands are different. And because we're able to do this, we're able to optimize the energy quite significantly. And in addition to some of the other changes we made on the Coolpit DH and some of the other components, we're able to reduce energy consumption compared to our previous generation of 5V up to 13.5%, which is a very significant change. And lastly, our HyPET 6E has incorporated many technologies that support the operation of rPET. And every HyPET 6E machine that is sold today can run up to 100% rPET. All the features we have in our toolkit of rPET is included in our 6E and also in our HPP 6E platform. And the reason why, when we talk about running rPET, historically when you have virgin PET resin, you can reliably expect that batch to batch seasonality, whether day to day or month to month, that your PET resin, the characteristics of your resin will be more or less the same. This can no longer be expected when you have rPET here. We're introducing another degree of variability here. And here we're seeing a lot of variation in rPET, depending on from one supplier to another. We're seeing variability in between seasons, because sometimes the bales come in at different times. And in the summer, they will collect bales in one way. In the winter, they'll collect bales in another time. And you have different types of bottles being collected, which will impact things like the dust level, the crystallinity of the resin, sometimes the pellet sizes. It'll impact the acetaldehyde and the haze. So all of this contributes to the challenges of running rPET, and we have incorporated many technologies to support customers in operating and managing this variability. So first thing what we do is we're offering our customers support in grading their rPET. So before you want to talk about the equipment, you need to understand the material that you're using. And we're offering their service together with our partners, where the customers can send in the rPET to us. And we will take a look at all aspects of the rPET, whether it is the IV, the crystallinity, the color, the dust level, acetaldehyde, and we will compare them to industry benchmarks to let you know what is the quality of your rPET. And then afterwards, we will, based on this data, we're able to give advice of what type of equipment you need and also what type of process you need to run. Some rPET might need one type of drying condition. Another type of rPET might need another type of drying conditions. Maybe you also need to look at your configuration of the equipment. Different rPET might require different type of requirements. So we start by understanding the materials, and here we're supporting our customers in being able to grade their rPET. And once you have an understanding of your rPET, here Husky is providing really a holistic approach to managing the variability of rPET right from the beginning of grading your rPET, as I mentioned in the previous slide. And then we have custom solutions in our resin preparation, our resin drying system, in terms of our hopper design and adding metal separators, cyclone filters, and oil condensers, integrated controls with the HMI to be able to operate and manage the rPET. Also an injection unit, we talked about high mix screw incorporated there. We have a best-in-class hot runner to be able to make sure that each single cavity in the mold will have the equal material and thermal temperature profile, and everything's homogeneous. Our hot runner ensures that every single preform is given the same amount of material. We also include our self-cleaning technology here to make sure that we manage the excessive dust. It's often generated when you run rPET. So when you have rPET, usually in the mold, you have more dust. It requires more cleaning, and our self-cleaning mold will help mitigate the risk associated with that and also make it easier for the technician to be able to clean the mold vents. We also have a closed-loop color control here, where we have integrated with our partners a vision inspection system that monitors the color of the preforms, and if the colors go beyond some certain specified limit, here we'll add a specific dose of color in the right quantities to make sure we establish the preform color back to baseline. And all of this connected to a special HMI with rPET screens that are able to manage the recipes, that are able to manage the set points, and the logic of running rPET here. So really a holistic solution in managing rPET right from the beginning until the preform inspection and closed loop color control. One of the real innovations that we developed in last couple of years, and I mentioned this briefly we launched this technology during DrinkTech in September 2025, is our vacuum drying system. So what this is it's a replacement for our traditional resin drying system. So historically, our resin drying system, you have positive air, forced pressure, hot air being blown into a hopper, which dries the preform. And here we've completely revolutionized that. We don't have one large hopper anymore. We have 4 separate smaller hoppers. And instead of using high temperature forced air, we are replacing that with a vacuum. And this has given us many opportunities for savings and improvements here. Number one, the energy efficiency of the vacuum dryer system compared to our traditional system, together with an oil condenser, is a significant energy efficiency savings of up to 30% here. The maintenance requirements is much lower here. If you're familiar with the traditional resin drying system, you have your desiccant towers. That one desiccant tower is in operation, drying your resin, and the other one and it goes to regeneration cycles here, and you have to replace the desiccant once in a while here. In the vacuum dryer, you don't have any desiccant here. You have lower maintenance requirements compared to your traditional hopper. Process consistency as well. In a traditional dryer, you have one desiccant tower being regenerated, the other one's being used. After you switch, every time you switch, the drying efficiency is very good because the desiccants are very dry, it's able to absorb a lot of humidity. But towards the end of that cycle, the desiccants are already quite humid. It doesn't work well as it did at the beginning. So by using the vacuum dryer, you linearize it, you flatten out the processing consistency across the board. We don't see this type of sinusoidal processing inconsistency that we have done in the past. And of course, what's really critical when you're running rPET is that, and what's the beauty of this technology here, you have 4 separate modules here. Only in the last module do we actually increase the temperature of the rPET up to 180 degrees. In the 3 prior modules, we have lower temperatures, and we're taking out that humidity and all the volatiles by using the vacuum here. And this is very important because This means that we're putting less heat energy into the rPET, which means that the rPET will degrade less. It will, you're preserving the IV, and you're preserving the color much better with the vacuum dryer. So we already have launched this technology, and we have installations all around the world, and our customers are very happy with this technology, with all the multiple benefits it brings. And last, I should mention, is fast resin changeovers. Before you had, let's say, a 10-ton hopper, and you want to change the color or change the resin, for example, you would have to run through all 10 tons of PET has to be flushed out. It takes a long time for that to happen. Now that we have 4 separate modules here, we reduce the resin changeovers from 8 hours, for example, 6 hours down to 2 hours here. So for all of these benefits here, a lot of technologies, a lot of our customers are adopting the vacuum dryer. And stepping beyond our equipment, we also support our customers running rPET with our Advantage Plus Elite program, which is now shipped with every single machine that we ship to our customers here. And here, this technology here, this program here is very supportive of our customers to make sure they're able to run 24/7. In fact, we are connected with our customers. Every customer machine is connected to Husky here. We monitor the machines 24/7. If we start seeing an issue on their machine, we will proactively call the customer to your appointed person, and we say, look, we are seeing some variables here. We're seeing that the dew point sensor on your resin hopper is spiking. We're seeing some issues, perhaps some hydraulic pressure jump somewhere here. We believe this could be the issue. Could you please take a look? So even before the customer identifies the issues, we see the issues in advance, and we're able to support our customers by calling you proactively to help solve your issues here. And we're able to support you remotely. We work with your technicians on site to solve the problems. And worst case scenario, if there is a problem, at least our technicians are familiar with the issues. We have all the data. So when our technicians come on site, we're able to support you in the best way. So this is a very useful program for many of our customers, especially for our customers who need support in the maintenance of the machine, in terms of running the machines. They really support and really appreciate having the Advantage Plus Elite technology. So to put everything together, when I start talking about the resin grading services and all the technology we're putting in our equipment and also the Advantage Plus Elite, the main goal here, the main theme here is we're trying to reduce the variability of rPET. When we talk about the bale quality and bale variability, we start talking about the recycling technologies are used out there. There are different types of technology. All of this will manifest as variability in your rPET. And what our purpose here is trying to minimize that variability as much as possible by providing the right technologies, providing the right services, Advantage Plus Elite to try to mitigate those risks as much as possible. And the less variability you're going to have means less downtime, it means less scrap, it means lower energy cost, and here it reduces your bottom line cost and improves your profitability. And taking one step back further, just beyond our technology and beyond the Advantage Plus Elite, we're really the only industry's complete solutions provider here. We're talking about here Husky Academy to help train your people, whether they're a beginner first time in injection molding, or whether they have experience, they want to have advanced processing training. We have a Husky Academy that can support them from end to end. We also have our factory planning and optimization team. This is a great team with many decades of experience in optimizing your factory, finding ways to run your operations in a more efficient way to reduce your bottom line cost, to look at the layout of your factory, to identify ways to reduce waste, ways to improve the workflows in your factory, where a dedicated team is able to support you in looking at your factory, and assessing your factory, and finding ways to optimize its operation and reduce bottom line costs, and also improve your productivity and increase your top line revenue here. So really, from end to end, Husky is really there to support you in making you as profitable as possible, reducing bottom line costs and increasing your top line revenue. And this concludes my presentation. So I'd like to thank you for listening for 30 minutes, and I'm here available to answer any questions that you might have.
Thank you, Philip. That was wonderful. That was insightful presentation, and all of us we enjoyed. We have a lot of questions also coming up because this subject is really so very relevant for our region in particular, as we are really moving from this space of PET to rPET, and a lot of areas you really touched, which is interesting, and you gave us an insight from Husky's side in all of those areas, which is wonderful. So let's take some questions, Philip, if it's fine with you, because a lot of interesting questions have come up from our customers, especially brand owners and some converters also. Starting with Almarai Kanin Shahidi is asking this question: how does the HyPET platform help reduce the kilowatt per kg of preform, especially for 24/7 operations, kWh per kg?
So there are several things that we have done with the 6E platform in comparison to our 5E platform that has helped reduce the energy consumption. So first of all, the high mix screw does give you the possibility of downsizing your injection unit with the same throughput. So if before you're running an EE 100 screw, today you might be able to run with an EE 85 screw with the same throughput, and this will reduce your energy consumption. We have also introduced and this is what I mentioned before, is our dual servo motor pump configuration. One is independently running with the injection unit, the other side is running with the clamp. So we're able to set the duty cycle and set the injection pressure independently for the clamp. The clamp has lots of motions, and so it needs a different types of flow rate and injection pressure versus the injection unit, which needs a different type of profile. So because we're able to separate out those two hydraulic circuits, we're able to significantly reduce the energy consumption of the injection unit. We've also electrified the shutter, so to shuttle between mold open and mold closing and clamp up, clamp down. We have now electric shutter, energy savings there. We've also added some updates. Our Copic DH, this is the part that is responsible to dehumidify the enclosure and also to supply cold air into the preforms. We've also made some innovation there that reduce energy consumption. So all the cumulative effect of all of this is around 13.5 up to 13.5. I would say minimum you'll get, I've seen a range of preforms, minimum of 8 to 9% across your entire catalog of preforms, up to 13.5% for some specific preform design. So it's quite a quantum leap compared to what we're able to achieve from 5V, and 5V was already a good platform in terms of energy consumption. So I hope I answered the question.
Yeah, sure. Let's go on to the next question. I hope it answers your question, Konain, but now this is another very interesting question from Shabik from Akhtia, Alain Water. Could you please explain more about the automated cleaning for the mold?
Okay. The automated cleaning is normally, or today, you want to clean your mold vents. You would open a mold. Sometimes you put the mold on the floor. Sometimes you keep the mold in the machine. Your technician would step in the machine or go in front of the mold, and you would isolate all the neck rings. If you have a 48 cavity mold, you have 48 neck rings, and you have to go to each neck ring and clean the mold vents. This is how it is historically done. Now with self-cleaning, what we're doing is that we keep the mold in the machine. We close the mold, but we don't close it 100%. We leave a tiny gap. So the neck rings are not completely closed. The two neck ring halves are slightly open. And what we do is we deliberately flash the mold. So we will put extra plastic to fill the preform, but also the plastic will go inside the neck rings into the mold vent. And liquid molten PET making contact with dust PET will stick together like glue, and the preform cools down. All the dust is now attached to this preform. You open the mold and you dump the preforms out, and you close the mold and you run production again. So you transform what is a 3 to 4 hour operation into something that takes maybe 10 to 20 seconds. And the beauty of this technology is that it's done uniformly. Before, your technician might have lots of energy. They'll clean the first neck ring very well, but by the time they reach the last neck ring of the 144 cavity, they're very tired. Their arm is tired. They don't clean very well. So you'll have inconsistencies in your vent cleaning. If you don't do the vent cleaning at all, what's going to happen is that the vents will get clogged. It means air cannot go out the vent. If air cannot go out the vent, then in your mold space, plastic cannot go inside the mold space. So you're going to end up with preforms with short shots. Maybe your preforms will not be fully formed out. you have sink. So it's imperative that we allow a path for the air to evacuate, and that's the purpose of the mold vents. But the mold vents, they collect dust over time, and it's imperative that we clean it. And this technology is a really novel way to clean the vent in a very automated way.
Brilliant. Thank you. Philip, we have a question from Avinash Rata from Grain Velocity. What initiatives are in place to reduce input resin costs for users, and how can you help in this process? And he's also asking, secondly, are there any polymer projects to help reduce the VPET and rPET preform weight for beverage applications, keeping bottle strength with Husky machines?
Yes, absolutely. And he touched on a very important point, because this is the struggle we're seeing with many stakeholders in the industry, especially in markets where legislation is being enacted, mandating minimum recycled content. And the challenge that they face is that running rPET means running with higher costs. The material itself has a higher cost. So what they're trying to do is to reduce the weight of the preform. We're seeing a lot of activity in customers might elect to remove material from the core body, and that will manifest into a lighter bottle weight in the body. There's some challenges here, because if you remove material there, it means the mechanical performance of your bottle will go down, the blowability will be more challenging, the shelf life will be a little more challenging. But some of these bottlers and converters feel like there's some room to reduce the weight there, and they can still meet the bottle specifications. Other types of converters and bottlers, they look at the neck. They see, well, I'm running PCO 1881 today at 3.8 grams. If I jump to the new standard, which is GMA 34, I can save almost up to 1.1 grams just in the neck alone by converting the neck. So we're seeing a lot of activities, especially in those markets where they're converting from virgin to rPET. Customers are very interested in running and finding ways to lightweight the preform. And you can lightweight your preform in different ways. And here at Husky, we have 40 years of experience doing this. We invite you to reach out to us and give us your portfolio of preforms, and we'll benchmark your preforms compared to industry averages. We'll give you comments about the mechanical performance and maybe the impact of shelf life and the blowability of your current design, how much material you can take out safely. We can provide you preform samples so you can test it out. You're running maybe a 22 gram today. We can give you samples of 20 grams, run it in your line, and see how it works. So we have a lot of experience to support you in lightweighting your preform. And the second part of the equation, if I remember the questionnaire, is that in order to be able to run lighter weights, you need to have the most consistent preforms, because rPET itself is more variable. If you want to reduce the cost of your preform and lightweight your preform, what you cannot have happen is that your rPET increases the variability, which increases the chance of bursting of the bottle, reduces the mechanical performance of the bottles, reduces shelf life, etc., etc. You need to make sure the preforms are as consistent as possible. And all the technologies I mentioned before, our best-in-class hot runner, our self-cleaning, our customized resin drying system, our vacuum dryer, all contribute to as much consistency as possible, so you can really push the limit in lightweighting and achieve as much cost savings as possible. It's a very pertinent question, because it's a question that many people in the industry are asking to mitigate the cost of higher rPET.
Sure, thank you. So many questions coming in. So quickly, we're going to choose 3 or 4 more questions, Philip. So Yusuf Al-Manai, he's asking this very interesting question. You demonstrated output increases of 15%, 25%, and even 33% in your customer base. What percentage of plants actually achieve these gains or those gains after startup? And what are the biggest operational barriers preventing others from reaching those numbers?
So it is strictly mathematical. If you're running a 72 cavity mold today and you increase to a 96 cavity, with the smaller pitch, the 45 pitch, we're able to put the 96 cavity mold within the tie bar spacing of what historically we can only fit a 72. So we're able to increase the productivity 33%. That's mathematical. There might be a slight cycle time impact. Okay, I'll be honest here. It might be 0.1, 0.2, so it might not be 33%, maybe 31% here. So for an existing machine, if you come to us and say you have a 225-ton machine, you want to put a 96 cavity, we will size that machine with the right injection unit, with the right throughput, with the right shot size, the right resin dryer to be able to accommodate a 96. Maybe customer says, I want to run 72 today, and I want to run 96 in the future. Or maybe the customer say, I want to run 144 cavity today on my 510, but I want to be ready to run 200 in the future. So we will size the injection unit, the resin dryer accordingly. If you have an existing machine in the field today, let's say you have an existing 2 to 5 ton machine and you want to run a 96 cavity, here we would need to take a look at, okay, what is your injection unit? What's your power pack? Do you have enough accumulators there? Is your injection unit enough? Is your shot size enough? We can do this type of analysis. Maybe for some preforms, it's easier to jump to 96 cavity because a preform is relatively lightweight. Your existing shot size, your existing throughput can be managed by existing machine. But we can also upgrade your machine as well to accommodate those larger cavitations. So Ben, I think there are multiple aspects to the question. Did I miss any point of the questionnaire?
Mm-hmm. Yeah. All right. So thank you. There's a very interesting question coming in from Vivek Chaturvedi. Of course, I had the same question. How to reduce the rPET yellowness in preform? Any additives recommended?
How to reduce the rPET? Sorry.
Yellowness, or let's say the clarity.
The L. Okay. The L and B.
Yeah,
okay.
Yeah.
So in this case, look, when we talk about the color variation, you will get the rPET spec sheets, and it will tell you the values for L, for B, and A, and all the other variables. What we contribute on our side is to make sure that the material is treated in the lightest and gentlest way as possible in the resin drying and in the injection unit, that we don't inversely affect it as much as possible. But there's going to be likely some type of degradation. You can see some yellowing, you're going to see some browning, potentially with some resins much more than other resins. What you can do, and what most customers do who are facing these difficulties, number one, they add a little bit of blue toner. So they have a master batch of blue toner. And here, of course, in our 6E, we have a closed loop feedback control where we have, working with our partners, we have a vision inspection system. It will monitor the color. And if the color goes beyond a certain range, then we'll add the blue color in specific dosage to bring it back to blue. So the combination of all technologies, from the mix-cell, from the vacuum dryer, all of that contributes to the minimum impact as much as possible in degrading the resin and therefore maintaining the clarity as was before. But as a worst case measure, we do have this closed loop color control that can restore to a uniform baseline that is requested by the customer. In some markets, customers are even brand holders are even trying to educate the customers that they should accept these type of colors, and that's just what it takes if you want to use rPET. And they have taken that approach where they say, look, we're not going to make our bottles blue. We'll just keep it brown, and the customers have gone to accept it.
Brilliant. Thank you. Anurag Srivastava is asking this question. Interesting one. Any differences in hot runners used in 6E from when compared to 5E?
Yes, we do have between 6E and 5E. I know we have an HPP 6E hot runner. I believe it's similar to the HPP 5E hot runner. So just on the outset, I believe the hot runners are the same, just to be honest. So I not aware of any changes in our hot runner.
Right. Okay. There's another very interesting question coming from Kanain Shahidi. How much can we reduce scope 2 emissions by improving kWh, kilowatt per kilo efficiency on HyPET systems, especially in regions like Saudi Arabia and UAE with high grid emission factors?
Okay, so here is the question you're asking, how to reduce CO2 emissions. Correct. Here? Okay, so one easy way to do that is lightweight to preform. Every kilogram you reduce from your preform weight, you remove 2 kilograms of CO2 emissions. Okay, this is one way. And also, just based on a machine, if you have a higher productivity over the same fixed install base with the same footprint on your machine. Now, of course, if you're running a larger cavitation, a higher productivity, especially these 45 pitch molds, you're going to have to upsize your resin drying system. You're going to have to upsize your injection unit. Of course, that's going to go up. But there is a fixed energy footprint that you have for your factory and the machine that will be distributed over the larger production base. And here you will have energy savings. And this has been our mandate since the first X-line machines, since the early 1980s up until now. We have improved our energy efficiency by 200 to 300% in terms of kilowatt hours per kilogram. And the HPP60 is the best in class in the industry in this regard here. And as I mentioned before, about energy efficiencies, what we've done with the dual servo motor pumps, the changes we made in our Pupik DH, also the output, the increased output, all have contributed to reducing your carbon footprint, so to speak, on the energy side. But on the preform side, you can also lightweight, and this will be a very big contribution also to reduce your carbon footprint as well.
Right. Okay, thank you. Yusuf was asking this question. Again, does the living mode continuously monitor cavity balance and predict maintenance requirements before flash or dimensional variation appears? Or is it primarily intended to simplify mold setup and startup?
So the answer to the question is yes. When we have our integrated mold alignment, there are 6 sensors which detect when the molds come together, make sure that the molds are aligned in the X direction, Y direction, Z direction, and also all the rotational angles, X, Y, Y, Z, etc. Oh, and to answer the question here is that the most important one with regard to flash is making sure that the mold comes together and you put a high injection pressure, that the mold doesn't slide open. We call it mold breathing. Here we have a lot of mold wear and we have the risk of flash here. So the integrated mold alignment does detect to make sure that the molds are properly closed, even during injection, which is very difficult for a technician to, by their eye, to make sure that the mold is staying closed even after injection. But the integrated mold alignment, it does catch that and make sure the mold is properly closed. If you start seeing the mold breathing, you can start increasing the tonnage of, let's say you're running at, I don't know, maybe on a 2 to 5 ton machine, you're applied maybe 180 tons, you can jump up to 190 to make sure that mold breathing doesn't happen, and you can ensure that flash is not there. So we do have the technologies there to make sure that the molds are properly aligned, to make sure that we have equal material being distributed. As each of the valve stems pull back, we have equal amount of material flowing to each and every single cavity. All of that's being monitored by our Advanced Plus Elite system. We can see exactly shot size of the material going into the system, and yeah. So I hope that answers the question.
Brilliant. We'll take one last question, Philip. This is a very interesting question. I'm sure many of our audience will like to hear from you. You mentioned rPET quality is now a cost issue. What is the realistic TCO difference between virgin PET and rPET preforms, especially with food grade levels for dairy application?
Very difficult to answer the question because it really depends on your application. It depends on your preform weight. It depends on the type of resin that you're using. It depends on are you talking about existing equipment, new equipment? Here, this is something that we at Husky can help you. If you have specific questions, if specific applications, I invite you to reach out to us. Give us your preform drawing. What type of resin? We need to see the type of quality of resin. We can do the inspection of resin. If you have excellent quality resin, and we have some cases, there are some resin producers out there that make really good quality resin. And even in those cases, they have to make some changes to the equipment. Some of those customers still have to change the mixel screws. Sometimes they still have to make adjustments to the resin drying process, even with the best quality resin. But with very, I would say, really mid-quality or even sometimes poor quality resin, it can really substantially affect it. Like sometimes you have to increase your cycle time by 2 seconds. In some cases, I've seen customers have to manage a 2-second cycle time impact because their resin quality is really poor. So it's very difficult to answer that question because it's really depending on the type of material. If you have, and this is what we're trying to do. We're trying to mitigate the risk. You know, customers can buy good quality resin and they can run on an existing standard Husky machine and probably get pretty good results with some changes. We're trying to shift the goalposts here by even with mid-quality resin, still try to mitigate the risk, still try to reduce the amplitude of that variability to still be able to run at 100% uptime, no increase in scrap, less downtime, same cycle time as before, so they can run with rPET in a more profitable way. Okay, but I invite you to come reach out to us to give us just this specific case, and we'll try to support you.
Sure. Thank you, Philip, for a very insightful and practical presentation. Right. Today's session has clearly shown that in a fast-changing PET market, profitability is no longer about output alone. It is about improving cost per part, energy efficiency, system productivity, floor space utilization, and consistent preform quality. And Philip really elucidated this very well to all of us this afternoon. I hope today's discussion has given our attendees, all of you, ladies and gentlemen, useful takeaways on how high output PET producers can protect margins while maintaining quality, reliability, and production efficiency. So, on behalf of Packaging MEA, I would like to sincerely thank Philip Parubets and also the Husky Technologies team for sharing their expertise with this today's webinar. So, big thank you also to all our attendees who have joined us this afternoon, taking out your important time and being with us. And thank you for your participation, and I'm sure it was helpful for you. Thank you once again, and we look forward to welcoming you to our upcoming Packaging MEA webinar. Thank you, everybody, and thank you, Philip, once again.
Thank you, Ben. Thank you, everyone. Have a great day. Bye-bye.
Thank you.